In this video, I'm going to do a conclusion for the total resistance lab with the series data. I'm going to place my cursor over each part of the grading sheet as I'm doing that part. So hope that this helps you to see it all put together. Okay, here we go. Hello, my name is Emily James, and I'm doing a conclusion for the total resistance lab. Our purpose was to figure out how the number of resistors affected the total resistance. We found that as the number of resistors increased, the total resistance increased when the resistors were connected in series. Below you could see, or on the screen, you can see my tables and graphs. The data table illustrates this nicely. As the number of resistors went from 1 resistor to 4 resistors in series, the total resistance went from 221 ohms all the way up to 886 ohms, clearly showing the trend that as the number of resistors increased, the total resistance increased. You can also see this in the graph. So in the graph, we've graphed total resistance versus the number of resistors, and we find a positive sloping line. The fact that the line has a positive slope shows that as the number of resistors increases, the total resistance increases. Now, if we take a more careful look at the line, we get an equation that's R equals 221.5 N times minus 0.05. Well, the 221 value looks an awful lot like the resistance of one resistor. And so we can calculate what the resistance should be using the formula that R equals the number of resistors times the resistance of one resistor. And here's what we get. As we can see, our formula is wildly successful. Our average percent difference is 1%, and we even have one of our trials with the percent difference of 0. This really does make sense. As the number of resistors increases, the total resistance is going to increase because each time the charge hits a resistor, it's got to slog through that resistor to get to the other side. Now, if you have more resistors, you're going to wind up with a harder time getting down the wire. The way a series is connected, a single charge has to travel through each resistor. And so, as the number of resistors increases, the total resistance increases. We don't have an awful lot of error here. If anything, the error is under 5%, which is what the resistors are rated for. So that's probably our biggest error, is that the resistances have some play in them. And then I guess also maybe detector accuracy. Finally, for future research, I might want to change this around so that I keep the resistance constant, and or I change the resistance. I don't change the number of resistors. I change the resistance and measure how much charge flows across the resistor from a given battery. Anyway, that's my conclusion. Thanks so much for taking the time to listen. Bye.